In this video, we're going to explore the law of sines to solve oblique triangles, which means they're non-right triangles. We're going to find the area of an oblique triangle using the sine function. And then we're going to do some applied problems with the law of sines. So the first thing we're going to do is just a little bit of a warm-up of finding the angles in degrees that satisfy these equations. So make sure that when you're doing this, your calculator is in degrees, not radians, because it's asking us to give us answers in radians. So, in degrees, not radians. So if I'm asked to find the angle that satisfies the sine inverse of 0.93, then in my calculator I make sure that I use the sine inverse button and I put in 0.93, and my answer is the angle, which is 68 and we'll go to one decimal place, 0.4 degrees. Similarly on this one, what I'm going to do is do the sine inverse of both sides, so I get theta is equal to the sine inverse of 0.6. I'm going to put that in my calculator, and I'm going to get 36 degrees. So theta on this one is 36, and to one decimal place would be 9 degrees. So again, now I'm going to use cosine, so I'm just make sure I have my cosine inverse instead of sine, 0.368, and theta here is going to be equal to 68.4 degrees. Something to think about in terms of when you're on a right triangle, when you get the same angle, what you know about it in terms of sine and cosine, something to think about. And then on my last one, I'm going to go ahead and do the cosine inverse of both sides, and so I get theta is equal to the cosine inverse of 0.5. So here theta is equal to 60 degrees. Now let's talk about what an oblique triangle is. An oblique triangle is any triangle that is not a right triangle. So just make sure that we've got our notations correct. Notice we have angle A, or we can call it alpha if we prefer. It is a capital A or alpha, and it has to be opposite my A. My side A, my lowercase a. My angle C or gamma, it has to be opposite my lowercase c, the side C. And then, of course, we have our uppercase B or beta. It has to be opposite the side B, which is a lowercase. Now, it doesn't matter how you label the starting, as long as those relationships hold true. So as you build your triangle, if you decide this is going to be C or gamma, just make sure you put C across from it. Similarly, if you decide that this is going to be B or beta, make sure you put B across from it. And then if you call this A or alpha, make sure you put the side A across from it. So it doesn't matter where you start with your triangle and how you label it, as long as that relationship of capital A or capital C and lowercase c are crossed, or gamma and C, and capital A, lowercase a, capital B, lowercase b are opposite each other. That is the important part. How you start your labeling doesn't really matter. So when we are looking at triangles, oblique triangles, we have the angle side angle, or the angle side, and how you say it is exactly what you have. So let's take a look at what I mean by that. So if you have the angle side angle, then you literally, as you say it, write down what you have. And it doesn't matter, again, which way that you start. I started down with C. I could have done angle side angle. As long as I understand that those relationships of gamma and C, beta and B, alpha and A are all maintained. The next one we're going to look at is the angle side. It doesn't matter how you have it. I have an angle side. So the important part is, when you know you have angle side, is that you have this relationship. You have one of the angles, and then you have the side opposite one of the given angles. The next one we're going to look at is the side angle. So side, and then the angle, which is opposite one of the two sides. So in this case, I may have gamma and C, and I have also B. This is what we call the ambiguous case, and what that means is that we have the possibility of having no triangles, the possibility of two triangles, or the possibility of one triangle. And then we have these other two, which is the side angle side and the side side side. And we're going to do those two when we do the law of cosines. So we're going to hold off on those two until we do the law of cosines. So going down here for the law of sines, the way that we define the law of sines is the ratio of your sine of alpha over A, the sine of beta over B, the sine of gamma over C. Now these are all lowercase. Another way in which you may see this is if I am solving for a side, then I will put the sides in the numerator and I will put the sine of the angle in the denominator. So you may see me write it like this sometimes because I'm solving for one of the sides. If I'm solving for an angle, I put my angles, so the sine of my angles in the numerator. If I'm solving for a side, then I put my sides in the numerator. Just makes a little less step, a little easier. So then we want to look at the ambiguous case where we have the side angle. Okay, so here's the ambiguous case. When I have an angle that is between 0 and 90, these are the two choices I have. I have the height of my triangle, H, is less than the side opposite my given angle. If that happens, then I have no triangle. My other case is that if my side is equal to the height, in that case I have a right triangle. The way in which I find my height is going to be this H is the height, where I have the given side and the sine of the angle not of the given side. So notice this is alpha and this is B. It is not the B sine B or B sine beta. It is B sine alpha. So depending on what you have, H can be equal to A, the cosine, or excuse me, the sine of beta, or it could be A, the sine of gamma, if you have A and gamma and C. So in this case, you would have C and you'd have gamma. In this case, besides A, you would have beta and B. You might also see this as the H is equal to B, the sine of gamma. In this case, not only do you have B, but you would have to have C. And then, of course, we have the last couple of cases when you have H is equal to C, the sine of alpha, or H is equal to C, the sine of beta. And again, you would have C and you would also have A, and here you would have C and you'd also have B. So the height really of it in itself, you don't want to memorize all these. You just know that you have two of the sides and it's going to be the height is going to be one of the sides multiplied by the sine of the angle not opposite the side you're using for the height. So don't have to memorize it as long as you understand it. You also have, in this case, again, we are looking for the alpha being less than 90 degrees. You could have the A is larger than the height of your triangle. Here's your height. But A is less than B. If that happens, then we could have an oblique triangle, or not an oblique, excuse me, an obtuse triangle. In other words, one of the sides is larger than 90 degrees, or one of the angles is larger than 90 degrees. Or you could have an acute triangle in which all of the angles are less than 90 degrees. So you end up with two triangles when this case happens. If H is if H is less than A still, but A is larger than B, then you only have one triangle, and there's no ambiguity. So here's your four cases, H, A, and when we're talking about these four cases, I want to be clear that we are talking about an alpha or an angle, or we'll just call it theta. We'll just do it generically. We'll call it a theta. The angle that is given to us is less than 90 degrees and is greater than 0. So in this case, we can have our first case, which is A is less than H. We have no triangles. It equals H. We have exactly one triangle. A is between B and H. Then we have two triangles. And if A is greater than or equal to B, then we have one triangle. All right, so let's actually do some problems. Let's talk about this. When we have an angle, and it is between 90 and 180. Well, the first case is, of course, that A is less than H, or A is less than B, and I'm given some angle opposite the side, and if that happens, there's no way that triangle is going to form. And I don't even have to talk about h on these. Don't even have to talk about h. If a is less than b and my angle is bigger than 90 degrees, I have no triangle. If a is greater than b and I have the side opposite and my angle is bigger than 90 but less than 180, I have one triangle. So the only time you have to really worry about the h is when you have an angle that's given to you that is less than 90 degrees. So let's go down here and then solve these triangles. Now, when we talk about solving these triangles, we mean that we want to find all three sides and all three angles. I have an angle and a side. This is not the ambiguous case. So I know I'm going to have one triangle, and now all I have to do is find all the pieces. Now, how you draw your triangle, you're going to notice I'm not drawing my triangle to scale, and I don't care because all I want to make sure is that I've got all of my relationships the same. So here's gamma, here's C. C is 48.3. My gamma was 143.7 degrees. Here is my alpha, and here is my A, and then of course that leaves my beta, and then my B. So the easiest part is, of course, is finding my beta, because we know that beta has to be equal to 180 minus the two given angles. So minus the 10.3 degrees, and then again minus the 143.7 degrees. Get my calculator out, and I'm going to get beta to be 26 degrees. So now I've found all three sides. I was given two of them, so that's the easy part. Now I just have that missing. I found the missing, not side angles. I found all of my angles. So now I'm going to find all my missing sides, and I'm going to use the law of sines. So I'm going to set this up as, and I always go back to what's given to me. I'm chasing a side, so I put my sides in the numerator. So I have 48.3 over the sine of my gamma, which is 143.7 degrees. And that's going to be equal to, and I'm going to have my A, which is what I'm chasing, over the sine of the 10.3. And I'm going to solve that. Simultaneously, I'm going to do the 48.3 over the sine of 103.7 degrees is equal to my B over the sine of 26 degrees. So when I solve this for A, I'm going to go ahead and multiply both sides by the sine of 10.3 degrees. And so I'm going to get A is equal to the sine of 10.3 degrees multiplied by 48.3 divided by the sine of 143.7 degrees. Similarly, I'm going to get B is equal to the sine of 26 degrees multiplied by 48.3 divided by the sine of 143.7 degrees. I'm going to put those in my calculator, and for A, I'm going to get 14. A will be 14. I'm going to run out to one decimal place because that's where everything else is, so I'll do 14.6. Similarly, for B, I'm going to get 35.8. And whatever my units are. So I have to go back and look. These are centimeters. Don't forget your units. And so now I've found all of my angles and all of my sides. And let's just stop and think about what's happening here. Now, notice that the largest side was my side C. And my largest angle was opposite my side C. And that makes sense. Largest angle is 143. My largest side is 48.3. My next largest angle is my B, which is 26 degrees, and it is 35.8. So that makes sense that those are opposite each other. And then my smallest angle, which is the 10.3, is opposite my smallest side, and of course, that makes sense. So let's take a look at another example. So let's just move all of this off to the way, and let's take a look at this one here. Move that out of the way. So I'm going to look at my A, B, and gamma. Again, this is nice, straightforward, not the ambiguous case, because of the fact that I have an angle, or I have a side, angle, and angle. But you're thinking, wait a minute, I can't use the law of sines without finding alpha. Well, we go back to the fact I'm not going to go this entire one because it's going to be exactly like the previous one, but I am going to say that to find alpha, it's going to be like before, 180 minus the 66.7 minus the 39.5 degrees. And then once you do that, you'll be able to find all of your missing pieces by using the law of sines. I wanted to really focus in on the next example here. I have alpha and A and C. So I have alpha, A, and C. That means I have the ambiguous case. So I'm going to go ahead and put everything in the right place. Here is the 39.6 degrees, and A is opposite that at 3.7. This is the 18.4. Now what I'm going to do, because it is the ambiguous case and my angle is less than 90 degrees, I'm going to check my H. The height of my triangle is going to be my side not opposite the angle, so it's going to be the 18.4, and it's going to be the sine of the given angle, which is the 39.6. Now I'm going to go ahead and do that multiplication by calculator, so 18.4 multiplied by the sine of 39.6. I'm going to get an H being 11.7. What that tells me is that I really don't have a triangle. There's A, but guess what? My height is 11.7. There's no way I actually have a triangle, so there is no triangle. So then let's take a look at D here. Again, I have an angle that is less than 90 degrees, so I'm going to build my triangle as before. How you put your angle, it doesn't really matter. I usually just start down here. There's no reason other than the fact I just do. Then I have 8.1. B, I'm going to put B over here. That's going to be the 10.6. And I'm going to start with my height of my triangle. So my height is going to be the opposite side, not the angle. The side not opposite the angle, so 10.6. And then it's going to be the sine of the 41.2. And this is in degrees. These are in degrees. Go ahead and put that in my calculator. I'm going to get 10.6 times the sine of 41.2. And I get a height of 6.98. What that tells me is I have two possibilities. My first triangle is going to look something like this, exactly how I expected it to look. My second triangle, however, could look like this. So let me do this in blue. My second triangle could look like this. This is still the 41.2 degrees. This is still the 8.1. And this is still the 10.6. So I actually have two possibilities. I have this angle here, which you can see is going to be bigger than 90 degrees. And let me just reference what I'm talking about. This is going to be gamma. That means this gamma here is going to be bigger than, this gamma is going to be bigger than 90, and this gamma is going to be less than 90. So I'm going to end up with two gammas, which also means that I'm going to end up with two c's. So I'm going to have c sub 2 here, and I'm going to have a c sub 1 here. Similarly, I'm going to have a beta 1 here, and I'm going to have a beta 2 here. So I'm going to have two triangles, so I have to solve twice. Let's start with first this triangle right here. So starting with this information, I'm going to go ahead and just jump into the law of sines. I am chasing angles this time, and so I'm chasing first the beta, because that's the side that I have is B. And so in this case, I'm going to go ahead and put my sines in the numerators. So I'm going to have the sine of beta over the given side B, which is 10.6. This is beta sub 1. This is my first triangle. And this is going to be equal to the sine of 41.2 degrees divided by my A, which happens to be 8.1. So then the sine of beta must be equal to 10.6, the sine of 41.2 degrees divided by 8.1. I'm going to go ahead and put that in my calculator. So I'm going to do 10.6 multiplied by the sine of 41.2 divided by 8.1. And I end up with the sine of beta is equal to 0.6198. And as before, like I started out with my warm-up, I'm going to go ahead and take the sine inverse of both sides. And so I'm going to get beta sub 1, these are beta sub 1, is going to be equal to, I'm going to do the sine inverse of that number I just found, and I get beta sub 1 to be 59.54 degrees. So from here, I would go ahead and solve for my my gamma 1. Of course, my gamma 1 is going to be 180 minus that 41.2 minus that 59. Oh, I'll give myself some more room. Let me just give myself some more room. Let me erase this. There we go. Give myself some more room. So my gamma sub 1 is going to be 180 minus my given angle, 41.2, minus my 59.54. So my gamma sub 1 will be equal to, so I'm going to get my calculator out and do 180 minus that 59.54 minus that 41.2, and I'm going to get my gamma sub 1 to be 79.26 degrees. Now these are all in degrees. Don't forget your degree symbols. So now all I have to do is find my, because I've got, for my first triangle, I have all 3 of my angles. I have 2 of my sides, so I need to find my C sub 1. As before, I'm going to go back to the value that was given to me. I always go back to my given values. This is going to prevent you, if you always go back to the given values, prevent you from rounding issues later. So always go back to your given ones. So I end up writing the same thing. I'm going to do my angle, or my side now. So I'm going to put C sub 1 in the numerator. And I'm going to have the sine of the 79.26 degrees. And this is going to be equal to my 8.1 divided by the sine of the 41.2 degrees. So C sub 1 is going to be 8.1 divided by the sine of 41.2 multiplied by the sine of 79.26 degrees. So my C sub 1 is going to be equal to, so I'm going to just do that really fast, 8.1 multiplied by the sine of 79.26, and I'm going to divide that by the sine of 41.2. So my C sub 1 ends up becoming, 12.1, whatever my units are, which are miles. So this is in miles. Now, I have found my C sub 1 for my first triangle, I found my beta sub 1 for my first triangle, and I've found my gamma sub 1 for the first triangle. Now I have to repeat this whole thing for the second triangle that's going to be built. Now, what I know, so I'm just going to talk a little bit about sine and all that stuff, is that if I were to do the sine, and we'll say 30 degrees, so the sine of 30 degrees in this quadrant is going to give me the exact same answer as if I would have had a reference angle of 30 degrees in the second quadrant. So it's going to give me the exact same answer if I do the sine of 150 degrees. These are going to give me the same value. So what that tells me is when I found the sine of my angle, which we found it to be sine, when I did this step right here, this one right here where I found a beta sub 1 is equal to 59.54, right? I did the sine inverse. Now when I do the sine inverse, it is only going to default me into the first quadrant because that's how sine inverse is defined. It is in quadrant 4 and quadrant 1, which means if I have a positive number here and I'm taking the sine of it, then I'm going to end up, when I do the inverse of it, to be in quadrant 1. However, this could be a reference angle and I would get the exact same answer if I use that as a reference angle in my second quadrant. So in this case, I had that 59.1 as being my angle. So I know that my 59, the sine of 59, because that was the angle that I found, 0.54 degrees, is going to give me the exact same answer as the sine of 180 minus that, using that as a reference angle, 54 degrees. These are going to be the same thing. So this tells me what my beta sub 2 is. My beta sub 2 is going to be 180 degrees minus that 59.54 degrees. That's going to be my beta sub 2. So 180 minus the 59.54. That gives me my beta sub 2. I think we're solving for beta sub 2, aren't we? Well, yes, we are solving for beta sub 2. We're solving for beta sub 2, and it's going to be 120.46 degrees. 46 degrees. And so my gamma sub 2 is going to be 180 minus my 41.2 minus my beta sub 2, which is 120.46. And so my gamma sub 2, obviously my triangle is not drawn well here. I just want to tell you it's not drawn to scale, clearly. So I have 180 minus the 41.2 minus the 120.46, and I end up with gamma sub 2 being a very small number in terms of degrees, and it's 18.34 degrees. Now, I would go ahead, so I've got my beta sub 2, I've got my gamma sub 2, and I would go ahead and find my c sub 2, so let's go ahead and do that. C sub 2 over the sine of 18.34 degrees is equal to, my given side was 8.1. 8.1 over the sine of 41.2 degrees. So my C sub 2 is going to be 8.1 sine of 41.2 multiplied by the sine of 18.34. I'm going to put that in my calculator. 8.1 divided by the sine of 41.2 and multiply that answer by the sine of 18.34, and I get my C sub 2 to be 3.87 miles, I believe it is. So I've found all of my missing pieces, and I have two triangles. So I had to find two betas, two gammas, and two C's, two side C's, I should say. All right, now let's take a look at the area of a triangle using the law of sines. We know from before that this is the height, and the way we define the height is either C sine alpha, could be C sine gamma, or C sine beta, or one of the others. It could be B sine gamma. It just depends on what you have. Notice, however, that we are now multiplying by the B. So it's BC sine alpha. It is AC sine beta. It is AB sine gamma, because what we are doing is we are doing 1/2 the base times the height. And of course, my height here, based on my triangle, which is going to be your A sine gamma, and then you multiply it by your base, which is B. So pay attention that when we are doing these, it is the two sides, not opposite the angle when we're doing the area of a triangle using the law of sines. So if you were asked to find the area of a triangle, you need two of the sides and the angle that is not opposite one of those two sides. In our first example here, we can go ahead and just jump right into it because I have A and B and I have gamma. So the area is going to just be 1/2 my A multiplied by my B, the sine of gamma. Nice, easy 1/2, 12.9 multiplied the 6.4 multiplied by the sine of 13.7 degrees. And I end up with, so 12.9 multiplied by 6.4 divided by 2 multiplied by the sine of 13.7. And I end up with an area that is equal to the we'll do 9.8, we'll go round to there. And then I don't have any units, so it'd be units squared. So square units. Let's take a look at my next example here. I'm looking at this one, and this one and this one are going to be similar. This one's nice, straightforward. We love that. But these two I have to do a little work for, because notice I have B and C, but I also am given beta. And that's kind of a problem because I need the angle not opposite. So I'm going to have to probably use the law of sines to find one of my angles, like alpha, because that's what I need. So I will go ahead and use the law of sine. So first I'm going to find my gamma. So I'm going to find gamma first. So I have the sine of gamma over the 19.7 is equal to the sine of pi over 5 divided by 23.5. Now notice that I have an angle in radians. I have pi over 5. So I've got to make sure that my mode is back into radians, not degrees, because they're giving me pi here, the pi over 5. So make sure I'm in radians, and so I'll have a 19.7 multiplied by the sine of pi, make sure you are in radians, divided by 5. And then that's going to then be divided by the 23.5. And so I'm going to get the sine of gamma is equal to 0.492, So again, make sure you are in radians. So if you get the wrong answer, check your mode. So I'm going to do the sine inverse of that number. And my number gamma is going to be 0.5152 radians. I'm in radians now. I'm not in degrees, I'm in radians. That's why it seems so weird and small, because it's in radians. So it's some number, some pi number divided by a number is going to give me that 0.512 radians. Now in this case, what I'm going to do is I'm going to do pi minus the pi over 5 minus the 0.5152 is going to give me my alpha. And that's what I've been chasing this entire time. So this time make sure that you are in radians. So pi minus that pi divided by 5 minus that 0.521. And so I end up with an alpha of being 0.9. We'll go with 0.2 actually. It actually is just 2 by rounding. Now that I have my alpha, now I can go ahead and find my area. So my area is going to be 1/2 my B value, which is 23.5, multiplied by my C value, which is the 19.7, multiplied by the sine of 2 radians. This is in radians. And so I'm going to end up with 1/2 times the 23.5 multiplied by the 19.7, and then multiplied by the sine of 2 radians. And I end up with my area is going to be 210, I'm going to 0.5 units squared. So in some cases you do need to chase down the angle that's not given to you. So in this case I have, to find that alpha. So I found the alpha, and the way I had to find the alpha is to find the gamma. And then once I found gamma, pi, which is 180, minus pi over 5 minus 0.5152, I got my alpha, and then I can actually find the area of the triangle. Now let's do some applications. So let's talk about navigation, surveying, marine navigation, and air navigation. They are 2 different things. So when you're doing surveying, it's similar to marine navigation. Marine navigation is measured, as well as surveying, is measured off the north and south. So you're going to have some angle that is going to be so many degrees off the north in the east direction, or so many degrees off the north in the west direction. So if you're talking about marine navigation, or you're talking about surveying, you will do it off of the north or off of the south. However, if you do an air navigation, it's measured off the due north, and always measured clockwise off the due north, and the angles are always between 0 and 360 degrees. So let's take a look at our first example here. We have an F-14 Tomcat. So the bearings that we're going to be doing, the navigation we're going to be doing is air navigation, even though we're leaving the carrier Nimitz, because we're talking about how the airplane is moving, not how the aircraft carrier Nimitz is moving. So when we're asked to solve for this, the first thing you want to think about is where are we? We are doing air navigation, so all of these values are going to be off of the north, the due north clockwise. So I'm going to start by drawing what exactly is going on. So we have the Tomcat, it leaves the aircraft carrier with a bearing of 34 degrees off the north. So I draw myself a little XY axis. Here's north. Off of the north, it's going to have a bearing of 34 degrees. So that's 34 degrees. The distance it's going to travel is 400 miles. After it's have gone 400 miles, it's going to then turn, clearly not exactly tight corner, but it's going to be a pretty tight corner. And it's going to then fly at a distance of, or at a bearing of 162. So from this, again, notice how I redrew my north. From this, it's going to go 162 degrees. So this angle is 162 degrees. And then it's going to then, at some point, again, notice how I'm drawing my axes again with the north pointing up. It's going to then fly back with a bearing of 308 degrees. So this flight back from the north is 308 degrees. Now, what we have to do is figure out what we have and what we are missing. So if I take a look at, let me just erase this here because I don't want this to muddy the water, so give me a moment to erase this. If I look at this first triangle, or this first turning point, that I know by parallel sides that since we're running north, they're both running north, this east-west is parallel to this east-west. So that tells me that since these are running parallel, so my first one down here in the bottom, actually let me do this with the correct colors. Let me erase this. Let me do this with the correct colors. It'll be easier if I do it with the correct colors. So looking at my first one in blue, right? So this is north, and this is 34 degrees. So when I put this onto my other axes, because these are parallel lines, then we know that this has to be 34 degrees. Okay, so this is this, and then this one is this one. Then I know that since I'm coming out at 162 degrees, that this little angle here has to be, that angle has to be 162, that is going to be subtracted from 180. So it's going to be 180 minus 162 degrees. So that little angle is going to be, I'm going to get my calculator out, 180 minus 162 is 18 degrees. So that little angle is 18 degrees. That means that these two angles combined, which is this angle right here, is going to be the 34 plus the 18. So that angle is 36 degrees, okay? And I found that because the angles are running parallel. Now I'm going to do the same thing with my red grouping here. So I'm now going to focus in on this axis and this axis. So here's my black axis again. So here's north. I'm running off 162 degrees, and down here is my second axis. Not drawn well, I might add. So let me do this. Oh, let me do that. Not drawn well. All right. So if this is 18 degrees, then this has to be 18 degrees because they're running parallel. Now, if the angle coming out, right, of this is 308. So this is my reference angle for 308. So I take 308, I'm going to subtract it from 360, subtract, and I'm going to get the reference angle. It's not the angle I want, but I'm getting close. So 360 minus the 308. So the 360, again, let me do my calculator correctly, minus the 308 is going to give me 52 degrees. That's the reference angle, but that's not the angle I want. The angle I want is this small little piece, this little sliver in here. And so that's going to be my reference angle, which is 52 degrees minus that 18. That's the angle here that I'm chasing right there. So I do that and I get 52 minus the 18 and I get 34 degrees. So this is 34 degrees. So now what I have, bringing this all together, let me redraw the triangle that makes my life a little bit easier to look at. So here is my triangle. We know this is 52 degrees. I don't know why I've got 360 up there. I don't know, maybe I just like 360. It's 52, and that came from the fact that I added my 34 over here. I added my 34 and that 18, so it's the 52 degrees, so that's 52 degrees. We know that this small little angle right here is the 34 degrees, and so I need to find this angle, and the only way I can, well, one of the ways I can do that, and oh, we know this other side over here is 400, is by doing the fact that I know 180 minus the 52 minus the 34. That's going to give me that missing angle. And then it's just a matter of using the law of sines to solve for this. So 180 minus the 52 minus the 34, and it gives me 94. 94 degrees. So that one is 94 degrees, and now I can just use the law of sines. If I want to know what distance the plane fly in the final leg of the journey, what they're asking for is this side C. We'll call it C, if you will. And so I'm going to go to the law of sines. So I have C over the sine of 52 degrees is going to be equal to the 400 over the sine of 34 degrees. And so the airplane 400, make sure I'm in radian or in degrees again. Don't forget that, because that will mess you up. Make sure you're in degrees. 400 times the sine of 52 degrees divided by the sine of 34 degrees. And so the final leg of the journey was 563. And how close do we want to go to the nearest foot? 564 to the nearest foot. Actually, that's not to the nearest foot. That is to the nearest mile. So that is 563.677 miles. And then we'd have to do that conversion because they want it to the nearest foot. So we're going to have to take and convert just this part. So the 0.677 miles is, when I do that conversion, I do the unity fraction. 1 mile is 5280 feet. So I'm going to take that decimal of 0.677 multiplied by 5280. My final answer is 563 miles and 3,574 feet is how long the last leg of that journey was. Let's go ahead and take a look at this example. Survey determines the angle of elevation at the top of a building. Now, we did these with right triangles. Remember how much fun that was? Now we can do it with the law of sines, which makes our lives so much easier. So here's the surveyor when he initially does this angle of elevation. So in other words, he's looking up. This angle of elevation is initially going to be 30.4 degrees. He then backs up 55.4 degrees. That's how far this leg is. When he does this new angle of elevation, it is 23.2 degrees. What they want is the height of this building to the nearest foot. So what I want is I want to be able to find this right here. I want to find that. Or I want to find this. So what I'm going to start out with, make my life easy, is I know that this angle right here, this angle, I'll do this in green, this angle right here is going to be 180 minus 30.4 because I'm on a straight line. So that angle will be 180 minus the 30.4, 30.4. That angle is going to be 149.6. So I can determine what this side is, and we're going to call this C. So using the law of sines and the law of cosines. Oh, and I probably need to find this angle as well. So now that I've found the gamma, then I know that angle is going to be 180 minus the 149.6 minus that 23.2 degrees. So that small itty bitty angle, 180 minus that 49.6 minus the 23.2. I'm looking at just the blue triangle here. What I mean by the blue triangle is I'm building this blue triangle. So I end up with 7.2. So this small little angle, we'll call it alpha, is going to be 7.2 degrees. Make sure you are in degrees, not radians. Now that I've found out all of my angles, I can now use the law of sines to find my C. So I have C over 149.6, the sine thereof, is going to be equal to my alpha and A. So my A was 55.4 over my alpha, which is the sine of 72 degrees. This, let me draw this in red so you can be very clear where I'm getting this number from. We are working on the blue triangle. So let me erase that. There we go. This is, put this in red so you can see that relationship, 55.4. So once I have found that, I can find what my C is. So I have C, which is going to be the 55.4 multiplied by the sine of 149.6 divided by the sine of 7.2 divided by the sine of 7.2, and I get that C value there. This is going to be 223.7. So C is 223.7. Now once I have found that C, I can go ahead and find this side as well. So I could have done that before. Yeah, okay, I could have done that before. So I'm going to call that B. So B over the sine of 23.2 degrees, 22 degrees is equal to, and I'm going to use the 55.4, the sine of 7.2. So I have B is equal to 55.4 multiplied by the sine of 23.2 divided by the sine of 7.2. That gives me 174.13. Now, I can go back to the right triangle stuff. So now I'm going to redraw my black triangle. This is a right triangle. This is 174.13. This is 30.4 degrees. And now that I have solved it this way, I can go back to my right triangle trig, and I know that using the sine of 30.4 degrees is going to give me this y value over 174.13. And so my y value, the height of my building, is just simply going to be sine of 30.4 multiplied by 30.4 multiplied by that 174.3, and the height of my building, y, my final answer, is 88.11 feet. And there it is. And I actually didn't need to do any of this, but I did, so whatever. Get a little extra for your money. And that's it.